Okay, if you're working on Windows, you need either Cygwin or another BES-like utility that you can do this, or you can do it with PowerShell, but PowerShell works a little different. So if you want to do this with PowerShell, you're gonna there's a presentation from Graham, and he did this presentation on PowerShell. So just take in the stuff and then look at his presentation to see how you can do it with PowerShell. Yeah, one of the reasons I have a Mac is that I like to have a command line and a good GUI integrated in one system, and also some commercial software, so I ended up using the Mac. A little bit about me. Well, the colors are there's almost no red in this picture. I started working halfway in the 90s for a little internet provider, one of the first commercial internet providers in Holland, was Euronet Internet. And I didn't know anything about packet capture at the time, so any problems we can solve by looking at packets. And then when I started working for a large bank in Holland, I got in contact with the tools to sniffing, like Sniffer Pro, or there was a distributed solution there as well. And I started using E3 at that time. That was in the end of the last millennium, beginning of the next millennium. And when I left there, I started working for a reseller of low balance equipment, and I did a lot of stuff on Altions and F5 network stuff and Cisco ACE, and there were a lot of bugs in the time, and so there was a lot of troubleshooting, and that's where I really got started using Wireshark and started developing stuff for Wireshark. In my spare time, I do a little diving and I like to watch art house movies, and I do a little pinball. It should be on there. I should put it on there. And I started my own company like 10 years ago. I started Symbit to do troubleshooting for my customers and do training. So today I'm going to do a lot of stuff. I'm going to do why you should use the CLI tools and how. I'm going to present the Wireshark CLI tools one by one, not all of them, but the most useful ones. I'm going to skip probably over the shell commands, because I think that should be knowledge you have. And I'm going to show some examples what you can do with it. The command line tools on their own are very useful, but once you start combining them with scripting or pipelining, then they get really, really powerful, and and they can do stuff that the Wireshark GUI can do. So why should you use the CLI tool? The easiest answer is when you don't have a GUI, right? But that's not all. You can do quick and easy analysis. I'm going to sit here because otherwise I'm standing in front of a screen for you. You can do quick and easy analysis because it's very quick to type in something. You don't need to click on all kinds of stuff. So it can be very quick. But the most important part is you can post-process the results. Whenever a CLI tool gives you some results, you can pipe it into another tool, and another tool, and another tool, and in the end you end up with something that you need. So the GUI is very powerful and interactive, but it has fixed functionality. Then of course you can do automation. Like if you have like 20,000 files and you need to extract something in those files, opening each file in Wireshark, getting it out, closing it, etc. It's very cumbersome. So with scripting, you can automate things by using the CLI tools. So, it's no, just go ahead. It's full. And so, what?
Do you have a tally already?
Come again?
Do you know how many people are here?
No. You can count them. Just go ahead. So whenever you want to use the CLI tools, I always focus on like what information do I need? What's the end result that I want? So I'm visualizing my output. Like if I want a table with something, or I want a count of something, or I want to extract data, or whatever, I try to look ahead and see what I need. And then I look, okay, what sources do I have? And that can be, of course, PCAP files, but it can also be other stuff. But for this presentation, we focus on PCAP, on network traces. So you have to know the format of those, you have to know what's in there, and then you need to know what tools are available. And that's what this presentation is about. What tools do you have in the Wireshark tool suite that's available to do this kind of stuff? And of course you need to practice, and experiment, and maybe be a little creative to get what you want. So, what are the command line tools that Wireshark has? It's tshark, dumpcap, capinfos, editcap, mergecap. So I'm gonna run through those and see what they can do. First of all, tshark, the most important one. tshark is just it's the CLI version of Wireshark. We have this Wireshark engine that does all the dissection, and both Wireshark and tshark hook into that engine. So it's the same dissection as in Wireshark, it's just displayed differently. It's similar to TCP dump, but TCP dump doesn't keep state. It doesn't do reassembly, and it has a lot less protocols than Wireshark or tshark. Does that mean I don't use TCP dump? Of course not, because TCP dump is very quick. It's quicker than tshark in some regards. So if I do pre-filtering on stuff, I use TCP dump. If I want to extract certain information, I use tshark. So you have to be flexible in that way. Just like Wireshark, tshark uses dumpcap as capture engine to separate the privileges that you don't want to run 2 million lines of code with root access. So that's why it uses dumpcap. And the standard options that you can use are -D for listing the interfaces, -I for selecting an interface. You can do -C if you just need like 10 packets to see what's happening on the interface. If you do get packets, you can use -C. -N for disabling name resolving, -L to make it line buffered instead of buffered, which means each packet will be printed out immediately instead of waiting until the buffer is full. Well, you can use a capture filter, read filter. You can slice the packets, write them to a file, or read them from a file. So the W or the -R are the most important ones, because that's how you save or read a capture file in PCAP format. The name resolving, timestamps, you can use absolute timestamps or just like Wireshark, seconds since beginning of capture. You can select it on the command line as well. And if you have a protocol running on a port that's not standard, you can use the decode as functionality by using -D, TCP port or UDP port equals, and then the port number, comma, and the protocol that you want it to be. Nowadays, a lot of protocols have heuristic dissectors as well. So if something is HTTP and it runs on a different port, Wireshark already recognizes it. You don't need to do this anymore. But for custom protocols that don't have those heuristics, you can do it like this. By the way, the presentation will be online. I see you typing a lot. It will be online, so if you're allowed to make notes, of course, but be aware that you can always get this. You can change preferences, just like in Wireshark. If you do want to turn reassembly off or on, you can use a -O, and then you need to find the preference that you need to change, and you can set the value for that. Especially when you do decryption or analysis of response times, you might want to enable or disable reassembly. Then there's a lot of output formats in, in tshark. You have the -V, which is verbose, and it gives you the whole dissection tree. So just like Wireshark dissects everything, it will show you all the dissection tree. By default, tshark shows only 1 line per packet, and with this format you see everything that's been dissected. It bloats your output, but you can find anything you need. And then there's -T, and then you can choose a format. You can choose, let's see, you can choose PDML, which is a packet XML kind of format. There's JSON these days, so if you want to have JSON output, you can use JSON output. The one I use the most is the fields output. In the fields output, you can select which fields you want in your output, and you get nice tab separated fields, which you can post-process. Then, just like in Wireshark, there's statistics. You can get a protocol hierarchy. You can get conversations, either at the Ethernet level or at the TCP level, or IP level. You get I/O statistics, so if you want to see in a file which filters are getting how many packets in which time frame, you can use this. And of course, you can do follow streams. One thing that's not in this presentation yet, but you can also export objects. You can export HTTP objects, IMF objects, or SMB objects. It's also all doable from the command line as well. So let's see how I need to get a second screen open. I'm going to get my notes up here so I can copy and paste, which saves a little time. Let's see if it works. So this is just the normal output when you select an HTTP response filter in tshark. And I think this is the wrong one. Demos. This is the one I need. So this is the normal output of tshark. It's a simple HTTP file with one request, and if you do the -v option, you can see that it's really extensive and it shows you all the fields and all the packets. So what you can do to minimize this is maybe use -o and say I only want to extend the HTTP layer, which means you get the frames, and whenever it's HTTP, you see it extends all the HTTP details, but it leaves the rest compressed. So that's how you can do that. If you look at the file sizes of all those, so here the normal output takes a little more over a K in characters. If I do the verbose one, it's 45K. Then there's the HTML one, which even gives you even more data or more output. So depending on what you need, it might be easier, or it might be best to use one format or the other. And if you look at the file itself, it was only 3K, so it really extends the output. Okay, let's get back to this. Okay. Okay, some more demos. Let's do demo 2 first. Where's my mouse? There it is. I'm going to skip this example of port 1234 because that's HTTP traffic and it's already been decrypted by Wireshark these days. This presentation is pretty old. I did this 10 years ago, but it's still, well, look at the crowd that comes to see it. It's still, I think, valid, and Janice asked me to do it again. When I did this first time, this would show you just TCP data because it was port 1234, which is not HTTP, but nowadays it's been recognized by HTTP. This is the command that you need to use when it is not recognized. You can change it like this. So that's why the example is in here. Then for protocol preferences, you know that to dissect SSL, you need to change the protocol preference. You need to tell Wireshark where to find the private key. So let's first see what is in this trace file. You can see that it's you can see there that it's client hello, server hello, and from the encrypted handshake message, you see that it's not decrypted, of course, because I don't have, I didn't tell Wireshark where to get the key. So if I use the -o option, let's emphasize this, and tell Wireshark where the key can be found, it does decryption. You can see now that you see finished message. Let's see, you see finished here, so that means that the decryption is working, and you even see that the HTTP requests are now decrypted. And of course, you can read out the whole HTTP traffic if you want. So on Wireshark, you can do it, but you can also do it in tshark by using the protocol preferences. Let's see. Yeah, there's a difference between, well, I'm going to skip this one. I'm going to show you quickly. when you do reassembly or don't do reassembly, the results are different. Like if you do reassembly, in the first situation I'm doing reassembly is true. You can see by the timestamps that the response time was 34 milliseconds. Let's see. That's interesting. I think I've got reassembly off in this one. I need to because reassembly is off. It shows the HTTP request. That's strange. I think the behavior has been changed in 2.6. This is the first time I present on 2.6. Yeah, it's 2.6. I think in 2.4 this was different, so I'll skip this. But it is important to know your tool, because I expected to see 70 milliseconds response time, because that's the time to the last byte of the response. So now Wireshark has changed, and my responses have changed, so whenever you use a new Wireshark version, you need to double check whether your analysis is still valid, if the output is still the same as it used to be before. I'm going to investigate this later on, because it seems very strange to me that it's happening like this. Okay, then some I/O graphs or some I/O functions. So I have this trace file with mail traffic, and I'm going to say I want the I/O graph, and I want to see the protocol hierarchy. And it shows a similar protocol hierarchy as in Wireshark. Like we've got Ethernet, IP, TCP. Under TCP we have SMTP and POP, and we've got ISMP. So this gives you an overview of the trace file if you don't have the Wireshark available or you just want it quickly. And next one is to see all the IP conversations in this trace file. As you can see, there's several clients connecting to, or there's one server connecting to one client connecting to several servers. I can split it out in TCP sessions. And it's sorted by the session that has the most frames. I think it was frames that it sorts on. It's either frames or bytes. If you look at this column, it must be frames. Okay, and you can also get like a table of all the traffic split up in certain time intervals, and for each filter it shows you how many packets and bytes there were. So if you have like several servers, you can put in the filters for those several servers, and it will show you which server got what amount of traffic in each time frame. So you can do very quick triaging of your trace file. Okay, back to okay. That was tshark. The other tool that Wireshark provides is dumpcap. As I said, it's being used by tshark and Wireshark to capture packets and save them to disk. But you can use it separately as well. I use it a lot. Whenever I do capturing on a system itself, I use dumpcap instead of the other tools. The options are very similar to tshark because they are passed to dumpcap. And the reason I use it is because it's very fast. It doesn't do any dissection, just capture the packet and dumps it to disk. It's stateless, so it can run forever. Well, of course, you need to take into account your disk space, but if you use a ring buffer, you can have it run forever. I've been using it at a customer for months at a time until the problem reappears, and I just say, okay, I want 1024 files of 16 MB, which means it's a 16 gig ring buffer that just collects traffic, saves it, and whenever the problem occurs, I can stop it and I can look at the packets. Then there's capinfos. Capinfos is a tool that you can use to get info on the trace file. So it shows you a summary of the trace file, and you can do that in a table. If you have like a list of trace files and you want to know which trace file starts at which point in time or ends in a certain point in time, You can use it with the -t option for table format. So this is actually the output these days is as you can see, this files from 2008, and the presentation is also from 2008. The output is now much more extended than this. You can see it, we'll show you in a minute. So you can select certain fields or the whole table or the whole thing. I will show you the table format in a minute. With editcap, you can select packets from a trace file. So either by time range, by packet range. So this means from example.cap right into temp.cap and keep only 1 to 1000 and packets 2001 to 3000. You have to use -r because normally editcap deletes packets from a trace file. So if you don't do -r, it will delete the packets that you specify. I don't know why that was created like that, but that's the way it is. And this is how you can do time frames, like all the packets between 11:40 on 17th of January till 11:50. In this, it's still, I need to change that, because the old behavior of tshark, which is way back until I changed it, was to do it up to here, and including the 59. But that makes it more difficult to automatically create ranges. So I changed it that now you need to do it like 11:50:00, and it will do up to, but not including that second. So actually, you need to change this slide. You can split files in chunks based on the amount of packets. So this will split the file in chunks of 1000 packets, or based on time. You can split it in chunks of 60 seconds this way, and you can remove duplicates, and it will keep a window of 5 packets. Whenever there's a duplicate within a window of 5 packets, it will remove it. And of course, you can change that window either to a size of amount of packets or a time frame, like 1 or 2 milliseconds, or whatever you want. Then, apart from selecting packets, you can use editcap also to edit packets or change packets. You can change the snap length. So if you did a full-size trace with all the data in it, and you need to send it somewhere and you want to remove data, you can post-mortem do the snap length change. For instance, 96. You can change the timestamps. So if you have a trace file that's made on you have 2 trace files on 2 traces, you can change the timestamps so they can match. You can change the link layer type if you want. I haven't used that before myself, but you can. Or the file type. If you have I don't know, these days everything is pcap or pcap-ng, but if you have a tool that only does pcap and you have a pcap-ng file, you can use editcap to change the file format. And if you have 1000 files, you can loop through them with a script instead of doing that manually in Wireshark, because in Wireshark, of course, you can also change the file type. Then there's mergecap. If you can split things in files, you need to be able to merge them as well. So mergecap is there for you. With mergecap, you say, okay, I want to have these 2 files, put all the packets back together in the output file. And it's being merged based on the timestamps in your capture file. They need to be in order within the file, but what it does, it opens up all the files and starts reading all the files. Okay, what's the next packet? What's the next packet? What's the next packet? And so it will be, if all the files are in chronological order, the output file will also be in chronological order. I haven't used that before, and I did a test once, and it's not quicker than using the standard option, even though it might be quicker because it just appends the files from one to each file to another file. Okay, let's do a little demo on that. Where's my? I keep losing my mouse when I'm switching between applications. It's annoying. So I just split the mail file into a lot of temp files based on the amount of seconds. So capinfos, taec, temp. So now you see that it split the file in 23 files, And if you look at the timestamps, you will see that they're all 1 minute apart. Of course, there's not traffic all the time, so there's a couple of differences, but they all end in like 27 seconds of the minute. By the way, if you have any questions, I try to get as far as possible in this presentation, but if you have any questions, please ask them during the...
I have one question about the dumpcap and tshark. You start continuous capture, and you have I guess ring buffer run. If you reset the OS or you PC, does it start?
No, it's just a process that started. So if the system shuts down, the process stops, and it doesn't automatically start up again. No. What was the next one? Okay, let's remove those temp files again. Now do it on packet count. As you can see now, each packet trace has 1,000 packets in it. And whenever I do mergecap of those files, it should be the same file as before. And the original was mil, and then the other one is new. Oh. And they differ. Why? Because the default format of let's see, mail. You see here that the default packet size limit is 64K. That's there. And in the new file, it's 256K. Let's see, where is it? Oh, I changed it also to pcap and G. So, well, you must take my word for it. The packets in these two trace files are the same. So you can split them and merge them back together, or split them, filter them, merge the filters once, etc. Okay. So what you see in this example is that the timestamp of the first packet is 2 o'clock in the night and 27 seconds into the minute. And if I'm changing the timestamp like this, so I'm subtracting 27 seconds from the trace file. If I look at the mail.new timestamps, you can see that it starts exactly at the minute. So this is the way you can change the timestamp if you want to synchronize two trace files and make sure that the timestamps are correct. You can use that with editcap, just like you can do it in Wireshark. But I don't think in Wireshark you can save the time difference. I'm not sure though. We should be able to save it. Okay. That's it for the demos. Let's go back to Keynote. Okay, we did that. We merged. We added the timestamp. So how do you get help when you, of course you are already getting help now, but if you run into troubles, use command -H. It will show you all the options that the command line utility has. And check that once in a while, because if there's a new version of Wireshark, there might be new options in the command line utility as well. So check it once in a while to see whether there's something new. There's the man pages, of course. You can find them on the Wireshark website or in your own system. So that's how you, or you can go to Ask at Wireshark, and people will ask questions about it. Okay, so far for the command line tools on their own. I had a piece of pineapple that's kind of. So sorry about that. So what are useful shell commands that we can use when we're going to pipeline the output of Wireshark into other tools? These are the ones that I'm going to discuss, the ones that I use the most myself. And that's a new one, Q. Who has known, not Q from Star Trek, but who has known Q as a command? Nobody? Q is a command that you, well, we'll see it later, but it's a command that you can take in a CSV or in any text file, and you can fire SQL statements at it. So that's kind of interesting to do. But let's start with the bash internals. So whenever you have a command and it has output, you can pipe the output of one command to the input of another command with the pipe command character. So ls-1t pipe head gives you the first 10 entries of your directory list. Then you can redirect the output to a new file, or and you can loop through things. So if I'm going to loop through 1, 2, 3 and I echo the word, it's going to say 1, 2, 3. If I do like IP address 1, 2, 3, and I loop through that, and I can do tshark, filter on the IP address, write to a new file, and done. I can get a cup of coffee, and it will automatically go through my files to select the IP address from a certain file. Then you have the backticks. Backticks will mean replace what's between the backticks by the output of the command of between the backticks. So you can use the output of one command and use that as text for another command. I use that quite a lot. When I loop through the files, for instance, like the 10 most recent files, sorry, the 10 oldest files in this case, I can go in the file and reading the first line, and I put it to a file with the name first line.txt. And you can do this with Wireshark also. You can loop through the output, like if I have a tshark command with the output of stream numbers, I can loop through the stream numbers and then do something with those streams. There's of course variable assignments, so I'm using combining the backtick now and assigning the output from the file, from the command to the backup file as a variable. Then you can cut things, either by position or by fields. You can sort the output, either normal or reversed, or numerical, which can be handy if you have numbers, of course. Or you combine it. So this command is my top 10 command, on which I always have in an alias. Okay, give me all the 10 biggest files or directories in this directory. Pretty handy. And we're going to use it a lot in the examples that we're going to see in a minute. Unique will do deduplication. So you sort the names you do, and then you do unique. It will give you a list of unique names in that file. And you can also say I only want doubles. Sometimes you need to know which entries were doubled. And what I like the most about this is you can count. So I can count stuff with this. Then sometimes you need to delete or translate stuff. So you can use a tr command. The deletion is the most useful, I think, because I often have like a file in which there's DOS character returns. I delete them with tr, like this. And then there's set. I do this very quickly because you can read the mem pages, and I want to get to the examples that really do something with the output. So set is a stream editor. It's a very powerful editing language, but I use it in a very simple way, just to delete stuff or to change stuff, or sometimes to extract stuff. Then there's awk. It's also very powerful. Like get a list of all your TCP states. That's what you can do with this. Or pipe the output from a tshark command. If the output is port numbers, I can do it like this to create a list of port numbers, or to create a display filter based on those port numbers. And we're going to see this in the examples that I have. Then, of course, I mentioned queue. We perform SQL statements on text files. So if I have the output of netstat in AN, I can get a list of all my states using this SQL query. Of course, the awk command was easier, but you can do it like this. Then, if the command line piping is not enough, you can of course script things, and you can use any favorite languages of your choice. I'm not sure what your language of choice would be these days. Like, who's a Perl head? No, a couple of old people probably. Python, more hands, yeah, I expected so. Bash, Also, yeah, well, okay. So any scripting language that you want, you can use it as a wrapper around all the things that you need to do with the tshark output. Okay. Let's have some cases using command line piping and some scripting. So the first case is, the problem is I need an overview of HTTP response codes. Of course, in Wireshark there's a nice overview of that, but if you want to have that on the command line, how can we do that? I want to have a table with the HTTP response code and a count of how many times it was in a trace file. And of course I have a capture with HTTP traffic. So I need to print the HTTP response code, I need to count it and make a sorted table, and this is what you would do. tshark -r example, print out of a filter on the response code, then print the response code and sort it and unique it. So let's see how that works via examples. So the steps I'm taking, there's my mouse again. So first I'm going to see if this is not the information I want. I want to have the response code. So this gives me just response codes. And now for the whole file, I'm going to sort that and unique it. So I have a list of response codes and a count of them. So that's one thing. Case 2. And I'm not sure how much time. Till 1 do I have? What? 11. Till 11. Oh, so I'm halfway. Okay. Then I can slow down a bit, maybe. So, case 2. I want to have the requested URLs and have a top 10 of that. Problem is, I need a list of URLs. And I want the output is a sorted list. And the input is, of course, again, an HTTP file. The steps I'm going to take is I'm going to print the HTTP host and the request URI. Okay, Wireshark now has a request full URI, so you don't need to do this, but this example will show you how to use set to change the output to something that you need. So I kept it in here, even though it's not necessary anymore. So I'm going to strip everything after the question mark, because those are the HTTP query, and I'm only interested in the URI. I'm going to combine the host and the URI to format in, so it's a nice normal URL instead of separate fields. And then I'm going to count those URLs and make a top 10. So the way that I'm going to do that, and I'm going to do it step for step again. So first of all, I'm going to read the example file, print the requests, and I print those two fields, and that gives me a list of the host name and the request object, and you already see that there's HTTP queries behind the URI, so I need to strip that. So first of all, I'm going to strip the URI of the query part, and I do that by using set. Let's see. So what I do is, whenever there's a question mark and anything behind it, until the end of the packet, or until the end of the line I should say, replace it with nothing. So it's a substitute of question mark and anything behind it till the end of the line, and it replaces it with nothing. Now I need to combine the two parts that I have in my output, and this is probably not going to work because there's this tab character needs to be expanded. Ctrl-V tab. So what this does is, let's see, where is it? Okay, so I'm removing the query part, and then I'm doing another editing. I'm going to say I'm going to substitute, and you can change anything. Now, normally you use a slash as a separator for your source and your destination, but you can change that to any character that you want. So I'm changing it to a hash because I'm changing something with slashes in there. So I change anything from the beginning of the line, and then all kinds of packets until the first tab. This is a tab character, which is in between here. And then anything till the end of the line, I'm going to replace that with HTTP. :// the first part, which is a back reference to this part, because this is between the parentheses, and the second part, so second part between parentheses. So it takes these 2 bits, deletes the tab character, puts HTTP :// in front of it, and combines them. So with set you can transform your output, extract things, and make it look like the way you want it to look. So we're almost there. Let's keep this one, remove the head, because I'm interested now for the whole file, not just the first 20 lines of the file. 20 packets, I should say. So this will do it for the whole file. And now I'm going to do a sort, unique, and pipe sort, min with universe numerical, pipe head. This means I'm going to sort all the URIs, I'm going to count them with unique, I'm going to sort reversed. Well, let's see what the output of this is. So now I have a count of all the URIs that were requested. I'm going to sort that in a reverse manner, and then take the top 10 out of it. So there's your top 10 of URIs that were requested in this trace file. And of course, if you need to do that for 1,000 files because you have like a ring buffer with 1,000 files each of an hour of traffic, you can automate this and write it to other output files and come back after you had your coffee. I don't drink coffee, by the way. It's tea. It's just the expression of drinking coffee. Okay. So this was the command that I used. And what did we learn? We learned how to remove stuff. We learned how to transform stuff. We learned how to create a top 10 of something. Let's see. I think this is in double. Okay. Yeah. There's now a field called http.request.fullURI. So the whole transformation was not needed, but it gives you an example of how you can do transformation if you do need it. So now we have a trace file when there's a couple of users and they requested stuff and their sessions are cookie based. We already saw on the last output there's a PHP session ID. So now I want I know in which session a problem exists, but I want all the data for that session. So how do I do? What's the output? I want to have a new capture file with the whole TCP sessions that contain, wherever in the session, it contains the cookie PHP session ID equals, well, I'm not going to read that. But. So the input file is again an HTTP traffic file. And the steps I need to do is, I'm going to select the packets that contain the cookie. I'm going to print the stream numbers for those packets. Then I'm going to create a new filter based on the stream numbers and use that filter to extract all the TCP sessions from the trace file. And of course I'm going to save them to a new capture file. Let's see how we can work that out. It's getting more complicated. And my mouse was gone again. Let's see. Example 3. Again, I start easy by just looking at, okay, do I have any sessions with this PHP session ID? And I do. HTTP request, and the cookie contains this value. Okay, no problem there. Then if I print the stream numbers, like this output, I added this output. I only am interested in a TCP stream number from the trace file. And you can see, well, it's counting up. There's nothing missing here, but if you do that, you will see that there are certain streams that don't have this cookie. So now we need to create a filter for this, for all these stream numbers. And I do that by awking. So what does this command do? I have this list of stream numbers. What I'm going to do is I'm going to print something, then TCP stream equals some other thing, The first thing is a separator, and the second thing is my first field, which of course there's only one field, is the stream number. Since separator is empty at the start, it won't print anything, and after the first run I change the separator to OR. This means I have TCP stream equals here, and there's only ORs in between them, not an OR in front of it. So this output is a valid tshark filter, or a valid display filter. So I can use this output to create something new with the backticks. Let's see what. Okay. Let me just do the command before applying it. No, that's not working because let's clear the screen for a bit. Okay. So, what's in here? You can see there's the first backtick, and there's the second backtick. So everything between these backticks, the output of that will be put in this other command. So this is the output of my display filter that I created earlier, and then I'm going to use that display filter as a new display filter for this tshark command, in which I again read the file and I'm writing the output to a new file. Nothing happens, of course, because there's a new file. There's your new cookie file. And if I do a capinfos on the original file and the new file, you can see that it's an extraction of the original file. So all the TCP sessions in which one of the requests in that session was this cookie, those whole TCP sessions are now extracted to a new file. Try to do this in Wireshark. It's not going to happen. Okay. So this is where tshark really starts adding functionality to the whole ecosystem. So again, I'm reading a file, I'm writing the output of the result after filtering, and as a filter I use the output of the first command that provided me with the TCP stream numbers, or it provided me with a display filter based on those stream numbers. So what did we learn? We can use the output from another command as an input for a display filter. We learned how to use awk to create the display filter. Okay. Now I'm going to take it one step further, because normally you don't know the cookie of the user, you only know the username. So you want to find out, okay, which session IDs were available for this user, because I know the username. So again, there's an output file, but now not only for this PHP session ID that we know before, but we want to do it for a certain user. And again, it's a file with HTTP data. So first, I want to print all the session cookies for the user. Then create a new capture file per session cookie, as we just did before. And then merge those files into a new file, and that's it. Well, that's a little harder than to do on the command line, because there's some looping and stuff. So I wrote a little script for that. And what it does, it reads the file that you want to use, at least it reads the user. It's going to look for all the cookies. So I'm reading the file, and in this case, the username is somewhere in the HTTP data, and I didn't do any fancy stuff in extracting it. Normally you would do a little more advanced filtering here to extract what you need, but as soon as the username is in HTTP, I'm going to print the cookie name, and since the cookie is a cookie name and then the value, I sorry, it's the cookie header and then the cookie value. I extract the cookie. And then for each cookie, I'm going to create a temp file based on the cookie name. And I'm going to do the command that I just created. So it gives me temp files, temp underscore, and then the cookie name. And after I've done that, I'm going to merge those files into the user file and remove the temporary files. This should give me so let's see, no. So there's my script. It looks the same as the one I had in my presentation, right? It's a little more convenient to read because it has coloring. And if I execute the script, I need to provide a file name, which is of course example.editcap, and now the user is Sake minus test1, I believe it was. So it found a couple of session cookies for this user, created temporary files, and created a new file, Sake minus test1. So if I open that in Wireshark, or tshark, but let's open it in Wireshark. Oh, it wants to open. By the way, I have on my Mac, I installed multiple versions of Wireshark because I sometimes want to test in one version and sometimes in another version. It's a bit of a pain, but it's doable. You need to zip or tar your original Wireshark, then install the new one, and then untar the old one. That will work. Then you can run them next to one another. So, file open. Let's see. Dropbox, SharkFest, SharkFest US, map files. So if I do HTTP contains Sake minus test1, those were the packets in which it found the username, and there's in that post is the session ID as a cookie. Again, in this one there's a session ID. So there was 3 session IDs, and yeah, you could. And it created all streams for this. I don't know how to show you that it actually worked, but you might want to take my word for it. Okay. If I'm going too quick, just say so. But I think the whole point is to get your mind open and see what you can do. I mean, and you need to create your own examples or your own, based on your own needs. You create scripts, not this ones, but similar ones. Okay. So what have we learned? We have learned to loop through things. We've learned to assign a variable, to use cut to select something from a variable or from a field, and to merge. Okay. Till 11. Okay. I think I'm running ahead of time. So, what if I want to have an overview of the minimum, average, and maximum response times per URI? Something Wireshark provides in the Wireshark doesn't provide it per URI, I think, but it does per response code. I want to have an overview of the URI, the count of the amount of packets, the minimum, the average, and the maximum response time. And of course, it's an HTTP data file again. I create a text file with all the requests, a text file with all the responses. I'm using Q to join the files and calculate the statistics. One of the things that Wireshark's not good at is you have a request and you have a response, and here's the URI and here's the response time. And how do I combine those? It should be be able to print the response time with the URI, right? It's a feature request, but it's not there yet, so we need to do it manually. So first of all, I need to get the request, right? So that's example 4, example 5. So these are the requests with the packet number. So I'm using -t fields. I'm separating with a, so not with a tab this time, but with a space character. Print the frame number and print the request URI. Again, I'm not interested in the query, so I'm gonna add pipe set and execute, substitute anything from a question mark till the end of the line with nothing. So that removes all the queries, and I'm going to save this in a file called request. Now I need the responses, so I'm going to do the same for the responses. So what I did is I get the response, all the responses, again field separator space. I'm printing the HTTP request in, which is a back reference to the frame in which the request was found. I'm going to print the response code, and I'm going to print the response time. And by having the back reference to the request, I can now join these two files with the SQL statement to create my output. So let's see. Oh, I didn't. Response. So now I have a query in which, let's see, I'm going to read from the request file and use it as request. I'm going to join that with the response file as response, and I'm joining them on the first column in the request and the first column in the response, which are the frame number of the request and the request in number from the response, so those should match. And then I'm printing the request, I'm printing from the request the second field, which is the URI. I'm counting those URIs. I'm creating the minimum response time from the response file, which is the third field in the response, and then, of course, the average and the maximum. And there's your, well, this is not nicely formatted, but there's your list of each requested URI, the amount of times it was requested, the minimum, minimum, average, and maximum response time. So if I have the one with 26, there's one that had 26 requests, I think. Where is it? There should be one that, well, here's one with 5 requests. So minimum of 1.35, maximum of 3.2, and the average was 1.85. So a quick overview of your capture file. So again, a little more readable. I created my requests. I created my responses with a back reference to the request in frame number, and I used those two to create this query in which I joined those two files on the request number and the request in number, and I printed the things that I needed. So we used to learn new tricks that we learned was to use queue. Okay. Then case 6, I think it's the last one. create a new trace file for a specific POP user that contains only his POP sessions. So there's a file with mail traffic, and there's SMTP traffic and POP3 traffic in it. So I'm going to read that file. This gives you an idea of a POP session. And I'm going to extract things for the user Sake -test2. And I'm going to use that to create a new trace file. So these are the steps that I'm going to take. So case 6. Oh, I need to do that live. It's not in my examples anymore. So let's see how that works. 5, 6. So I'm going to get an idea of the trace file. So port is tshark -read example. I think it still is. No, it's mail. I tcp.port equals. Okay, so this is one session, and you can see that there is a user Sake -test1. So there's also a user Sake -test2. You see that there's passwords in there. So I need to extract that. So I can use parameter So now I'm using single ticks because I needed to have the quotes within the filter. And you can see that there's packets where there's a user, Sake -test2, but there's also one in which it was used as a password. So I don't need that one. So I'm going to use and pop.request.command equals user. Oh. So now I deleted the session in which it was a passphrase. So these are all the TCP sessions that have this POP user. I can now do -t fields, tcp.stream number. These are the stream numbers that I need. I pipe that to, actually it's easier to pipe it to XR. This is a new way of doing things. Now I have all the stream numbers in a line, and if I'm using backsticks around this, I can use tcp.stream stream in, and then use this around it. Okay, so this is a new filter. Let's see what it looks like. So that's the filter that it creates. TCP stream in. This is a new way of doing things in version 2. And I can use this filter. I'm not sure whether I can use backtick in backtick. So let's see what happens if I do another backtick. Oh, sorry, I don't need to. So this is my filter, and so I'm using it as a filter. tshark min reads mail dot pcap min write Sake -test2 dot pcap, and I use this as a filter. And if I now tshark read Sake -test2, and I use the filter pop request not equals user, it should now show me only Sake -test2. While in the original file, it had sessions for another user as well. So now based on the username, I extracted the TCP stream numbers from all the POP sessions. Based on those sessions, I created a new file with all those streams.
Doesn't that new file only actually contain the actual filter? Do you actually need a filter when you're reading it?
No, you don't. But I wanted to show you only the user commands. But if I just read the new file, you can see that it contains the whole session.
I got you.
Yeah. You should read the mails there. They're fortune, output of fortune. Okay. Ten more minutes. Okay. Okay, so I did this by hand, and of course, we can loop through all the users because you saw that there were 2 users. So I can loop through the users and do this again for each user. I think we're going to skip that because I don't think that really. So now there's a challenge for you. Given the input file, create something like this as an output file, in which for each user, print me the time in which it tried to get his mail, how many messages were on the server for him, with how many octets. So, yeah, you might want to try and mail me the result if you find something that that works. If you need any help with that, feel free to mail me, and I'm glad to help. So, in summary, what did we do? We looked at the CLI tools, which ones are available, and based on the options that they already have, they're very powerful. But we did some scripting to make it even more powerful. And if you use little building blocks, like the whole Unix and Linux ecosystem does, and you combine those, you can do very powerful stuff. So, any questions? Yeah.
The dedupe with the editcap, what is that based on?
Again.
Dedupe?
Yeah, the dedupe.
With criteria?
I think it's based on the hash of the packet. So it calculates the hash on the packet, and then it does the dedupe based on that hash. So if you have a packet that's in different VLANs, then it's not considered a duplicate. It's only a duplicate if the full packet is exactly the same. So whenever you do a span port and you forget to do you do a VLAN span and you forget to do RX only, it will give you a duplicate packet for each packet that you can dedupe it with this. Yeah. Does that answer your question? Okay.
And more of a comment, a lot of those tools are available to Windows natively. You can download a packet, but for all the Windows users, you do that with Windows.
Okay. Is that since which version is that?
Pardon?
Which version of Windows?
Windows 10, Windows 7.
You mean all the best-like things, or?
Like said, awk, ref.
Okay, I didn't know that. That's good to know.
Together. I actually learned that from Christian
Okay.
several years ago. So
Okay.
I do that quite a bit, and it's nice. It's not quite as powerful as Linux, so if you're Linux, that's probably a better way. But
No, but you see that I use very simple examples, and they're not really complex commands. It's the building up on things. Yeah, that's a good point. So, if you use Windows 10, you're good to go. More questions? Yeah.
Dumpcap ring buffer management, it does a good job while that process is running. But if you have a reboot or something and you want to bring it back,
Yeah.
is there a way to put dumpcap into the same context it was in to
No.
maintain those files again?
Yeah, I understand your point, but there's not at the moment. No, there should be, but then you need, like if you make a start script that starts automatically. Yeah, no, there's not. Yeah, exactly. So if you reboot, you have to remove all the files first and then start capturing again, but then you lose your history. Yeah, I understand your point. Write a patch and submit it. Yeah, it's maybe a little bit off remark, but yeah, we could change that, but it needs some interest from somebody to start working on that. Yeah.
When you print, so if you're, you know, you can display all your HTTP requests with tshark to print. If you included the time, what's the default time format it shows?
The same as in your active profile, or sorry, the same as in your default profile.
Okay.
Yeah. Yeah, but you can change it with -t and then another file format, another time format. But the default is the same as your default profile, unless you select a profile on your command line. You can select a profile with -C and then your profile name, and it will use the output columns and everything from that command. You can even do coloring, but I haven't used that yet. So since the new version, you can do coloring on the command line as well. I haven't used it yet. Yeah. Yeah. No more questions, or? Well, thank you for joining. If you do have questions,